Need an AI that can call your Python functions to fetch real data without writing complex orchestration code? We'll create a React agent that automatically picks between a weather function and a search tool, then shows exactly which function it called to answer the question.
Import DSPy. Hash define your tools as functions. Def get weather city, SDR. Get the current weather for a city. Hash in a real implementation. This would call a weather API. Return F. The weather in city is sunny and 75 degrees F. Def search web query, SDR. Search the web for information. Hash in a real implementation. This would call a search API. Return F search results for query, relevant information. Hash create a React agent. React agent equals DSPy, React. Signature equals question answer. Tools equals get weather, search web. Max iters equals 5. Hash use the agent. Result equals React agent. Question equals what's the weather like in Tokyo? Print result answer. Print tool calls made. Result trajectory.
This demonstrates agent-driven tool orchestration, where a language model selects and executes Python functions based on natural language input. The code shows a React agent pattern that automatically routes questions to appropriate tools through signature matching, with the agent managing the entire interaction flow. The distinctive aspect here is how standard functions become AI-callable tools simply by being included in the agent's tool list. The implementation works by wrapping functions in an agent that handles both reasoning and execution. When given a question, the agent evaluates which registered tool can fulfill the request, calls it with the extracted parameters, and returns the result, all while tracking the complete sequence of tool invocations. The functions themselves remain unchanged, maintaining clean separation between business logic and AI coordination. This approach provides a straightforward way to connect language models with existing code. Developers can integrate functions as tools without modification, while the agent handles the mapping between questions and function calls. The pattern shown here works well for simple question-answering scenarios where tools return immediate, deterministic responses, though it assumes the agent will only need single tool interactions for the given input. Let's break it down line by line.
Import DSPy.
This imports DSPy, the framework used to create the React agent in this example. It provides the base class and tool integration system demonstrated in the following code.
Hash define your tools as functions. Def get weather city, SDR.
This defines getWeather, a standalone function that returns hard-coded weather data for a given city. The type annotation, city, SDR, and return type, SDR, explicitly declare its input-output contract, while the docstring provides a clear purpose statement for tool discovery.
Get the current weather for a city.
This docstring defines the function's purpose for both developers and the React agent. It's how the agent identifies that this function should be triggered for weather-related questions in the city parameter format.
Hash in a real implementation. This would call a weather API. Return F. The weather in city is sunny and 75 degrees F.
This is a mock implementation returning static weather data. It simulates what a real API call would return, letting you test the agent's workflow without external dependencies.
Def search web query, SDR.
This defines a mock web search tool with a string input and string output, matching the signature pattern used by the React agent. The function stub returns placeholder results since this example focuses on agent orchestration, not actual API integration.
Search the web for information.
This docstring provides the natural language description that DSPy's React agent uses to determine when to call this function as a tool. Clear docstrings are required for all tools in the agent's toolset.
Hash in a real implementation. This would call a search API. Return F search results for query, relevant information.
This placeholder returns a hard-coded response string that echoes the input query, simulating a search API call without making actual HTTP requests. It lets the React agent example run locally while preserving the expected function signature and return type.
Hash create a React agent. React agent equals DSPy, React.
This instantiates a DSPy React agent configured with our two tools, the weather function and web search function. The agent will use these specific tools to process the single hard-coded question about Tokyo's weather in the next line. This is the core component that coordinates tool selection and execution for our example.
Signature equals question answer.
This defines the agent's input-output interface, declaring it takes a question parameter and produces an answer response. The signature acts as a type hint for the React framework, constraining what the agent can process.
Tools equals get weather, search web.
This registers the two functions as the agent's available tools, defining exactly what actions it can take. The agent will use these specific functions when processing the question about Tokyo's weather.
Max iters equals 5.
Limits the agent to 5 reasoning iterations. This prevents infinite loops by capping how many times it can call tools or refine its response.
Hash use the agent. Result equals React agent. Question equals what's the weather like in Tokyo?
This executes the React agent with a specific question about Tokyo's weather. The agent processes this single input and returns a result object containing the generated answer.
Print result answer.
This outputs the agent's final response to the console. It shows the answer generated after the React agent processes the specific question about Tokyo's weather.
Print tool calls made. Result trajectory.
This prints the agent's tool invocation history from result trajectory, showing the exact sequence of function calls made to answer the question. For this specific Tokyo weather query, it reveals whether the agent used get weather, search web, or both. DSPy tool integration pattern. The code demonstrates how Python functions like get weather and search web become AI-callable tools when passed to DSPy. React, with the agent selecting and executing them based on the question input. The hard-coded weather response shows the basic tool execution flow, while result trajectory tracks which tools were called. Each tool must include a docstring, as these become the AI's instructions for tool selection.
The tool that never calls itself answers every question.